Hello class, welcome to this video on MCLA Chapter 13 review. So we're going to go over each of the questions in the review, starting with lesson 1, Chapter 13. So number 1 says find the mean, median, and mode, if any, for the given data, round to the nearest tenth if necessary. If there's more than one mode, enter your answer as a comma-separated list. Okay, so first we need to find the mean, median, and mode. So let's go ahead and do that. So in order to find the mean, remember you have to add the numbers, divide by how many you have. So we have 12 plus 52 plus dot 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 all the way to 54. And by the way, you are putting these answers on a separate sheet of paper, right? Because I'm going to be writing outside of this a lot because there's just not going to be enough room. Okay, so you get 221 divided by 7, which is 31.6. Okay, so now we're going to go ahead and sort the data. So if I sort it, I get 12, 15, 18, 27, 43, 52, and 54. And so there are 7 numbers, which means that the fourth number has got to be the median. Okay, so that's the median. Okay, so we got the mean, we got the median, and then the mode. If you look at the data, there are no repeats, so no mode. Okay, so that's number 1, and then we're going to look at part A. So part A, if there is an 18 that's added, then there's going to be two 18s, in which case the mode is going to be equal to 18. Okay. For part B, it says if there's an 18 and a 52, then there's going to be two 52s and then two 18s, so then there's going to be two modes. Okay. And then the mode is going to be 18, comma 52. All right, that's it for number 1. So number 2, the following table displays the ages of female actors when they starred in their Oscar-winning Best Actor performance. All right, so find the mean, median, mode. Again, same thing. So in order to find the mean, we need to add up the data. So let's go ahead and do that here. So if we add, I'm going to do this. Change that there. I'll just delete this. Okay, so we're going to add the numbers up, divide by how many we have, and we're going to go 41 plus 33, dot, 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 all the way to 55, divided by, now there's 36 data points here, actors, actresses, and this will give you 1,439 divided by 36, and which is approximately, now if you round it to the nearest tenth, it's going to be 40.0. Okay, because it's going to be 39.97, which if you round it to the nearest tenth is going to be about 40.0. All right, and then now we'll have to sort the data, of course. So go ahead and sort that. So go ahead and write out the list. We have 21, we got 25. In fact, we'll just, what we'll do instead is we'll type up the list so you know how it's going to look like. Okay, so we got 21, 25. All right, so I went ahead and typed up the numbers and in order. So you got 21, 25, 26, 28, so on and so forth, all the way to 80, just to save some time. And so if you find the median, now you have 36 numbers here, right? So 36, which means there's two middle numbers. So that means it's going to be between the 18th and the 19th number, because 36 divided by 2 is 18. So this is going to be 10 here and 18 here. It's going to be between the 18th and the 19th numbers, between those two. So you find the median. It's just adding them up, divided by 2, but since they're the same number, it's just going to be 35. Okay, and then look out for the mode here. Now the mode, there are quite a few numbers here, 2, 4, 5, so there's 5 33s, so the mode is going to be 33 here. Okay, so 3. During the 12-hour period, the temperature in the city dropped from a high 41 to a low of negative 38. What was the range? Okay, so the range is the maximum minus the minimum. It's going to be 41 is for the max, and then minus the minimum is negative 38. And the double negative turns into a positive, so it's really 41 plus 38, which is 79 degrees Fahrenheit. Okay, pretty simple. So now let's look at the weighted mean. So number 4, in some 4.0 grading systems, their students' GPA is calculated by assigning letter grades to the following numerical values. So here's your scale, and we want to find the student's GPA. Okay, so to find the GPA, remember that the formula for the weighted average, the weighted mean, so the weighted mean, I'll just say WM, is the sum of the scores times the weights divided by the sum of the weights. Okay, so in this case we have, we're going to go ahead and do the different grades. Here are the grades, right? And here are the weights. So for the course grade of B, it's a 3.0, I'm sorry. For a C plus, it is a 2.33 according to what they said, right? And A minus is 3.67, and the D is simply a 1.0. Okay, so we're going to use those for the grades, the score X, and then the weights are the course units. Okay, so we got so let's list out all those. So we have the score of 3.0 times the weight, that's 2 units, plus the score of 2.33 for the C plus, times the number of units is 4. So this is essentially our X, this is essentially our weight, okay? And plus 3.67 times 3 plus 1.00 times 4. And then they're going to divide that by, add the weights up together, 2 plus 4 plus 3 plus 4. All right, and then just got to do the math here. So we get about 30.33 divided by, for the top, and then there's 13 units on the bottom. So that's going to give us 2.33 for the score, for the GPA. All right, so number 5, use the 4.0 grading scale system, and number 4, in order to find the GPA. So the same thing, we're just going to use the same scale. So here we got an A, which is 4.00, C plus is 2.33, B minus 2.67, 3.0, and then 4.0. Okay, so again, we're going to do the same thing to find the GPA. We got the score, 4.00 times 3, 2.33 times 3, 2.67 times 2, 3.0 times 4, and 4.0 times 1 credit. And then add the credits together. And that will give you 40.33 divided by 13 credits. So the average GPA is 3.10. Okay, so hopefully that made sense. So now we're looking at the next section. The following standard deviation. The following table gives the average annual admission prices to U.S. movie theaters for the years 2006 to 2015. So they give you the prices here, the admission prices. Find the range of standard deviation for this sample. Okay, so the range is pretty straightforward. You just take the largest minus the smallest. So the largest is $8.17 minus the $6.55. And that's going to give you $1.62 for the range. Okay. Now for the standard deviation, we're going to need to do we're going to need to set up a table for this. This is where you'll need another sheet of paper. You know, this is where you need to show your work. So first we need to find the average. So we're going to find the average by adding the prices and dividing by how many we have. So we got $6.55 plus $6.88 all the way to $8.12, and we had 10 admission prices. So we get 7633 divided by 10. So it's going to be 6.6 6.6 So that's going to be our average. Our average price is $7.63. And now we're going to set up a table for the standard deviation. So we have $6.55, so on and so forth. Okay, so I went ahead and added the 10 prices here, just the data points that we had in the original problem. So now we're going to need to, for the second column, we need to do x minus x bar. So we need to subtract each of these prices. We need to do each of these prices minus the average price. So 655 minus 763. Okay, so 655 minus 763. And that will give us our first price. In fact, I'm going to do that off to the side, just so I don't have too many things going on. But you'll want to show your work for the first, one at least. Okay, and that will give you negative 1 point. And so you got about, negative 1.08. Okay, so for your difference, and then we keep repeating that. So 688 minus 763, so on and so forth. So the next one will be negative 0.75, and we'll just keep doing that. And in fact, I'm going to be more accurate with this. I'm going to do this to 3 decimals, even though you can do 2 decimals, but I'm going to be more accurate and I'm going to have more decimals. So in that case, this will be 1.083. So I'm going to do that, and I'm just going to have an extra decimal for these. All right, so this is what I get when I subtract. I do the x minus this x bar right here. Okay, so now what we're going to do is we're going to need to square these numbers. We're going to go ahead and square each of these numbers. We're going to do for example, this number raised to the second power, and then we'll do that on the calculator, see what we get, and we should get approximately, this is just rounding, 1.173, approximately, rounded to 3 decimals. Okay, so that's going to be, when you do this, these are all going to be positive. So the next one, if I square that on the calculator, I should get 0.56723 decimals. Okay, so this is what I get when I add those numbers, or when I square those numbers. So now what we're going to do is we're going to add these numbers together. So we're going to do the sum of x minus x bar squared. So we're going to add this column, the last column, and we get 3.017. Okay, so now remember this formula for the sample standard deviation is S equals the square root of the sum of the deviations squared divided by how many numbers we have, take away 1. Okay, so we just found the sum of the squared deviations. That's this total, the last column. Okay, remember the second column are the deviations, how far are away from average. The third column, the last column, is the deviation squared, the squared deviations. So we add them up. We already did it. So we got 3.1017 divided by, we have 10 numbers, take away 1. So just replace this with 9 when you do the calculation, just so that you don't make a mistake with the calculator. And you get about 0.58, $0.58 for your standard deviation. Okay, all right, so now we're looking at number 7. So now we're looking at number 7. I've cleared out some space so that we can continue working on number 7. All right, so number 7 says the fuel efficiency in small miles per gallon of 10 small utility trucks was measured. So here it is, find the range of standard deviation. Okay, so the range, again, is pretty straightforward. You take the maximum, which is the largest value, which in this case, so we got 32 minus 15 equals 17. So the largest minus the smallest equals 17. All right, and then we're gonna go ahead and put these set these numbers up, we need to find the average. So we're going to add these up by how many we have. So 22 plus 25 all the way to 22 divided by, we have 10 numbers. So that gives us 237 divided by 10, which is 23.7. So there you go. So now we need to set up our chart like we did. We got 22, 25, so on and so forth. Okay, so I went ahead and added those added those 10 numbers to my table. Now let's go ahead and do the next column. So x minus x bar, these are the deviations. So again, show your work for at least one of them. So we get 22 minus 23.7. The first number is 22 minus the mean of 23.7. That gives us negative 1.7. Okay, so we got negative 1.7, and then we'll continue adding the next numbers. So 1.3, so on and so forth. Okay, I did that. So now we're going to do the squared deviations. So square the second column. So negative 1.7 squared. It's about 2.89. So run that to a couple decimals. So we get 2.89. This is 1.69. 7 times 7 is 49. So 0.49. 10.89, so on and so forth. Okay, went ahead and did that. So now the squared. So now we're going to add the last column, which is the sum of the squared deviations. So we get 164.110. All right, so our standard deviation equals the square root of the squared deviations, the sum of the squared deviations over n minus 1. So we got the square root of 164.10 divided by, we have 10 numbers minus 1. And you get about 4.27 on the calculator. Okay, so there's our standard deviation. Now we're on to lesson 3, percentiles. All right, so in a reading test, Mitchell's score of 455 was higher than the scores of 5,678 of the 8,150 students who took the test. Find the percentile rounded to the nearest percent for Mitchell's score. Okay, so remember that the percentile of x, for example, are the number of values less than x divided by the number of numbers times 100. Okay, so for Mitchell's score, so percentile of 600, Mitchell scored, oh no, was it 600 or no, I don't remember. 455. So Mitchell scored a 455, and it says that that is higher than 5,678 of this 8,150 students. Okay, so this is my n, and then this is the number of values. Now it says his score was higher, which means that these scores were less than, right? And that's exactly what we're looking for. These are values that are less than Mitchell score, which means that this is just going to be our numerator. And then the denominator is 8,150 times 100. Doing that calculator, you get about 70. So it's about the 70th percentile. All right, and that's that one. So the next one, on a placement examination, Tyler scored lower than 5,752 of those students who took the exam. Find the percentile round to the nearest percent for Tyler's score. Okay, so now we're going to do percentile of Tyler, basically Tyler's score. And it says we don't know his score, but we do know his score is lower, which means that these scores were greater than his. So what we got to do is we have to that means these scores are greater than his. We have to subtract this from that in order to get how many scores were greater than or were less than Tyler's. Okay, so we got to do 10,467 minus the 5,752, and then divide that by the 10,467 because that's the total. Okay, so now upon doing that, let's see what we get. So that means 4,715 of the scores were higher than were lower than Tyler's. I'm sorry. Because Tyler scored lower than that, that means that these scores were higher than Tyler's. But these scores here, 4,715, are lower than Tyler's. And that's what we wanted. Okay, so 4,715 over 10,467 times 100, and then we'll convert that to percentile. All right, if we do the math, we get about 45.05, which is approximately the 45th percentile, because we're rounding it to the nearest whole number, to the nearest percent. Okay, all right, so that's it for number 9. So now we're going to do number 10. All right, so number 10, Mary scored at the 70th percentile on a test given to 1,390 students. How many students scored lower than Mary? Okay, so this time we're given the percentile and we want to know what Mary's score is, right? So what we're going to do is we know that it's percentile equals number of values less than x, right? And x is going to be Mary's score, right? Or the number of students. This is what we want. The number of values less than Mary. Let me just say less than Mary. Divided by n times 100. Okay. Now they told us the percent is 70th percentiles, right? So we're going to put 70 equals, and then we have the number of students less than Mary. We are going to call that x, okay? Because we don't know what that is. Divided by the total number of students, which is 1,390 students, times 100. Okay. So basically, we're going to divide by 100, divide this off, and basically just convert that 70 into a decimal. So we got 0.70 equals x over 1390. Multiply both sides by 1390, so you can get rid of that. So do a little bit of algebra. Okay, so you got 1390 times set 0.70 is 973. So that means there are 973 students that scored lower than Mary. Okay, and that's what we're looking for. All right, so now we're looking at number 11, percentiles given a data set. Okay, so first we need to sort the data. So we're going to put the data in order. So let's sort that here. So it's going to be 1, 2, 3, 4, 5, 6. Hold on, it's here. So 7. We got 8, 2 nines. We have 2 nines right here, and then a 10. Okay. 2, 4, 6, 8, 10, 12 numbers. Okay, so 12 students. So now we got to find the percentile for a score of 3. So now the score is 3. So we're going to take the lower score, or the first 3. We want the percentile to be lower than that, less than. So that means there's 2 people that scored less than this person who had a score of 3. Okay, so the percentile of 3 is equal to 2 numbers less than that over 12 times 100. And so that's going to be about the 17th percentile if you round it to the nearest whole percent. Jim scored approximately the 67th percentile. What score did he receive? Okay, so this is similar to what we did. So remember, percentile is equal to the number of values divided by how many? Okay, so we got percentile equals number of values less than what Jim in this case, right? Divided by n times 100. So he's at the 67th percentile. So we have 67 equals X, because we don't know how many values are less than Jim. And then there were 12 students, so times 100. Okay, so again, like before, we're gonna divide by 100, essentially converting this to a decimal. So we get 0.67 equals x over 12. Multiply both sides by 12. And we get x is equal to approximately, if we were to round it, 8 students. 8 students below Jim. Now, they're not asking for that. They're asking for Jim's score. So since there's 8 students below Jim, we would need to find out how many students. We would need to count out 8 students. So 1, 2, 3, 4, 5, 6, 7, 8 students below Jim. That's 8, which means Jim's score has to be an 8 if there's 8 below him, right? So that means Jim's score is an 8. Okay, so Jim's score is equal to 8. Okay. So number 12, in a class of 15 students, their heights given were as follows. Find the percentile for a height of 180. Okay, so we're gonna go ahead and type these numbers. So let's say sorted. We're gonna need to sort these data points. So 151, or there's 255, so on and so forth. Okay, so I went ahead and just kind of listed them in order, typed them up. So we have these 15 numbers, and we want to find a percentile for a height of 180, right? So that means this is 180, right? So we want them to be less than that. So how many people are less than that is we got to count these, right? So that turns out to be 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that are less than 180. Okay, so the percentile of 180 is equal to 10 people out of 15 times 100, and that's about the 67th percentile. Okay, so that's A. And then B, what Jane's height is the 80th percentile, so what was her height? So that means, okay, 80th percentile, we're going to basically go shortcut this. We know it's going to be 0.80 is equal to x divided by the total. The total is 15 people, okay? We know we have to divide by 100 and all that, but I already did that here, okay? You multiply by 15, and so that gives us x is equal to 15 times 0.80 is about 12. So there's 12 below Jane. So then we can figure out, okay, well, 12 below Jane. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that means Jane, that means Jane has to be this height because there's 12 people below her. So Jane's height is 185 centimeters. Okay, hopefully that made sense. So now we're looking at z-scores. So number 13, a data set has a mean of x equals 51 and a standard deviation of 8.5. Find the z-score for each of the following, round to each z-score to the nearest hundredth. Okay, so the formula for the z-score is z equals x minus mu divided by sigma, or you can convert the mean into x bar and then the sigma into s instead of using that symbol, the symbol for sigma. So basically it's value minus mean divided by standard deviation. That's essentially what the z-score is. So the value is 65 here, so let's go ahead and do that. So we get 65 minus the mean. You can ignore this. Let's just say the mean is 51, so it really should say x bar or mu, but just ignore that x there. So the mean is 51 divided by the standard deviation is 8.5. And there you go. So then do it on the calculator, round it to the nearest hundredth, you get 1.65. This one, same deal. Value 75. It's the same mean and same standard deviation. So it's just practicing calculating the z-score. You get 2.82. This one is 30 minus 51 divided by 8.5. So you get approximately negative 2.47. And the last one is 55 minus 51 over 8.5. And you get approximately 0.47. All right, and that's it. So number 14, which of the following three test scores is the highest relative score? So you need to do is figure out, you got to compute all the z-scores and then figure out which one's the largest. Okay, so you got the mean, standard deviation, and score. So z equals value minus mean divided by standard deviation. And that's going to be negative 0.37. Again, value, mean, standard deviation. So we're going to calculate that. All right. And then we get a negative number here as well, negative 1.55. And then lastly, we get 540 minus the mean 920 divided by the standard deviation, which is 102.9. And that's going to be about negative 3.69. So they're definitely not they're not all relatively equal because they're different numbers here. They're different z-scores. We can see, remember that the highest z-score is the less negative z-score. Okay, the greatest number is the number closest to the most right on the number line. Okay, so we know that negative 3.69 is like all the way out here, and negative 0.37 is here. So this number. Negative 0.37 is more to the right on the number line, so that's the greatest, okay? That means this is the greatest relative z-score, the highest relative z-score. So the answer is A. All right, so number 15, random sample of 1,500 oranges showed that the mean amount of juice per orange was 7.4 fluid ounces with a standard deviation of 1.1 fluid ounces. The z-score for one orange was 3.15. How much juice was produced by this orange? Round to the nearest tenth. Okay, so we know the z-score formula, right? It's mean minus, or value minus mean divided by standard deviation. Okay, so value minus mean divided by standard deviation. Now they tell us the z-score is 3.15. So we get 3.15 is equal to the value. We don't know the value. The value is the juice produced by the orange, which we don't know, right? That's the question mark. So it's going to be x minus the mean was 7.4 fluid ounces. And the standard deviation is 1.1. Now, technically, this is a sample, so really we should be using the x bar formula. So let me use that here instead, because they said a sample. So we're going to say x bar divided by s, okay? But those are just a change. This is just a difference in symbols. All right, but either way, the formula is still the same. So we're gonna do is we're gonna multiply both sides by 1.1, and that's gonna cancel this out. So we got, and then I'm gonna write this on the left side. So I'm gonna write this out first. So x minus 7.4 equals 1.1 times 3.15. Then I'm going to add the 7.4 to both sides. And that will give me my formula, if you will. So we get x equals 7.4 plus 1.1 times 3.15. But in any case, however way you want to set it up, we're going to get about 10.9 for the score if we round it to the nearest tenth. All right, so number 16, a test involving 380 men ages 20 to 24 found that their blood cholesterol levels had a mean of 182 and a standard deviation 44.2. The z-score for one man was negative 1.58. What was his blood cholesterol level? Again, same deal. So we're going to do z-score equals value minus mean over standard deviation. I'm going to show our work times 44.2 on both sides. We get x, so basically these cancel. So x minus 182 equals negative 1.58 times 44.2. Then we're going to add the 182 to both sides, right? X equals 182 plus this. All right, and then we're gonna do the calculation, round it to the nearest 10. Because it did say, oh, round it to the nearest hundredth here. It says that there. So about 112.16. Okay, in this case, the units are milligrams per deciliter. All right. So that's it for number 16. Then now we're moving on to quartiles. All right, so a survey was given to 14 students. One question asked about the one-way distance the student had to travel to attend college. The result in miles are shown in the following table. Find the first, second, and third quartiles for the data. All right, so we're just going to find quartiles. In order to find quartiles, we need to sort the data, right? So we're going to go ahead and sort that real quick. So it looks like we got 2, 4. We got a couple 10s. Got a 14. Got a couple 20s. We got 34, 38, 40, 44, 56, 64, and 70. Okay, so now we're going to find the median. So find the middle number. There are 14 students, so there should be two middle numbers, because 14 is an even number. Should be between the 7th and the 8th number. 2, 3, 4, 5, 6, 7. So it's got to be between these two. That means we've got to add these two numbers up, divide by 2. Okay? So our second quartile is 20 plus 34 divided by 2. So it's going to be 54 divided by 2, or 27. That's going to be our second quartile is 27. Now our first quartile, we're going to deal with these numbers here. So 2, 4, 6, 7. There's 7 numbers. That means there's one middle number. The middle number is the fourth number. Okay, so this right here is my first quartile. And then 2, 4, this right here, that's my third quartile. So those are all of my quartiles. Okay, pretty straightforward. So number 18, we're going to do the same thing, find the quartiles for the number of prescriptions. We're going to need to sort this data. So we're going to put it in order. Let's do that first real quick. So we got a bunch of 7s, bunch of 8s, so on and so forth. Okay, went ahead and typed up the numbers and put them in order. So we get 2, 4, 6, 8, 10, 24, and 36. So there should be 36 days here. Okay, so now we're going to find, since there's 36 numbers, that means the 36 divided by 2 is 18. So it's going to be between the 18th and the 19th number. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's going to be between the 18th and the 19th number. So there you go. It's going to be, so that's your second quartile, which is 11 plus 11 divided by 2, which is just 11. And now we're going to look on the left side to find the first quartile. Now there are 18 numbers on the left side, so we also have two middle numbers here. So it's going to be between the 9th and the 10th number, because 18 divided by 2 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, between the 9th and the 10th number right there. That's your first quartile, is 9 plus 9 divided by 2, which is just 9. The 9th number here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's between the ninth and the 10th number. That's your third quartile. So it's 14. You're adding these two numbers up, divided by 2. But again, it's just going to be 14, but I'm showing my work. All right, those are your quartiles for that. Right? So number 19, draw levels for 10 adults are shown below. Draw a box and whisker plot of the data. So again, we're going to need to put these numbers in order. So we'll go ahead and do that here. So we got 164, 170, 172, 182, 185, 208, 214, 221, 254, and 310. All right, so clearly we have our minimum is 164. We need to find our quartiles, of course, but our maximum is 310. All right, so our median, second quartile is the median. There are 10 numbers, so it's got to be two middle numbers. So it's between the fifth and the sixth number. 1, 2, 3, 4, 5, 6. Okay, so it's between these guys. That's your second quartile, which is 185 plus 208 divided by 2. And that turns out to be 196.5. Okay. Now, 2, 4, there's 5 numbers to the left and 5 numbers to the right. So there's only one middle number. So there you go. So this is your um, first quartile. And 1, 2, 3, here's your third quartile. All right, so now we can draw a box plot for the data now that we have our 5-number summary. So we're going to try to do the best we can to craft that. Now the smallest is around 160, the largest is around 300 something. So we'll go from 160 to 320, okay? When we do our scale, and we'll go by 20s here. All the way to 320. You have to be consistent when you do your scale. So you can't, you have to jump by the same, okay? So the minimum is 164, so this is 170-ish, so it's going to be like around here. So you can do a little dot there. And the first quartile is 172, so it's like halfway between 160 and 180, a little bit more than half. Right there. That's going to be your whisker right there. And then you have your median, which is 196.5, almost 200. You have 221, so a little over 220 to third quartile, and then your maximum is 310, which is halfway here. All right, and then we'll go ahead and draw the box, and then of course the whiskers. All right, and there's your box plot, guys. And these are cholesterol levels, just to label the axes. All right. So number 20 says the table below shows the heights in inches of 15 randomly selected NBA players and 15 randomly selected Division One NCAA players. Draw box and whisker plots for each of the two data sets, placing NCAA below NBA. Okay, so first we're going to need to put these in order because they're not in order, of course. So go ahead and put in order. So you see the smallest for NBA is 75. Yeah, 75. Where 76 is. Oops. So on and so forth. Okay, so pause the video and then I went ahead and put these in order. So this is what I got for NBA. So now we got to do NCAA. Okay, so the smallest for NCAA is 73 here. And there's a couple 73s. About 3, in fact. 74, so on and so forth. And all right, so these are now in order. Go ahead and I went ahead and did that. So we can go ahead and to do our summaries. Okay, so our 5-number summary. Okay, so for NCAA, we got the minimum is 75. See, the maximum is 85, but we'll get to that. So we got Q1, Q2, Q3, and maximum. Okay, so there are 15 numbers, which means that there's one middle number, and it's got to be the eighth number. 1, 2, 3, 4, 5, 6, 7, 8. That's got to be our second quartile. And we can do the NCAA as well. While we're at it, because they all have the same amount of numbers. So 78 and 76, 2, 4, 6, 8. Yeah. So 78. Oops, that's first quartile. That's the wrong one. So second quartile. 78 and then 76. All right. Now we gotta go to the left of that and to the right of that to find the first and the third. Now 2, 4, 6, 7 numbers to the left, which means that there's only one middle number. Okay. So 1, 2, 3, 4, the fourth number. So that's going to be our first quartile. And then our fourth number here are for that. And then 1, 2, 3, 4, 81, and then 78 for our third quartiles. And maximum here is 81. Okay, so that's what we got. So now we're going to go ahead and draw the box plot. So we're going to do the smallest is around the 70-ish, the largest around 80-ish, 85 or so. So we'll go by, we can probably go by ones and just go from 70 to around 70 to 85 or so. We'll go ahead and do that. Okay, 80, and then we'll end around 85 here. Okay, and then these were um, the heights. So these were heights in inches. All right, so then we said, okay, so we got NBA is 75. We want NCAA below NBA. Okay, so we'll do NCAA first. So NCAA, we got 73. First quartile, 74. Then we got 76. We got 78. And we got 81. Okay, so this is NCAA, and then we'll do NBA above it. So NBA is 75 for the minimum. Then 76. Um, oh wait, so then okay. And then we have 78 for the second quartile, and then 81 for the third, and 85 for the maximum. All right, there you go. And then you can make some descriptions, comparison of those scores. We can see that NBA is more spread out, right? There's more spread for NBA, but it has a greater range. It has a greater median, right? So things like that. So you can tell. I'll give a lot of information from that. All right, so now we're in lesson 4, frequency distributions and histograms. Number 20, about to measure the lengths of hundreds of snakes. Use the relative frequency frequency distribution below to answer the questions. All right, so here we go. What percent of the group of snakes was less than 11.75 inches long? So less than 11.75, that means it's from here on, which means we need to add these numbers up together, okay? So it's going to be 15.3 plus 12.0 plus 0.6, which is 27.9%. What is the probability that one of the snakes selected at random was at least, so that means greater than 11.75, but less than 13.75? So at least meaning we're going here, right, and down, all the way to 13.75. Now we're going to include that here. So at least 11.75. Okay, so that means at least 11.75, so we're going to include this. And then but less than, so that means we're going to include this. So we're going to include these two. All right, so it's 35.9 plus 20.7 is 56.6%, and then we want to convert it to a decimal, so it's 0.566. Just move the decimal place to the left twice. All right, there you go. So number 21, the following histogram shows the distribution scores for a history test. So they give you the frequency histogram. How many students scored at least an 84 on the test? So we got, this looks like 9 students here for 80 for oh, it says at least an 84. So that means it has to be this bar right here. So this bar is 6, this bar is 2. At least an 84 means greater than or equal to. So that means it's going to be 8. Okay, so it's going to be 6 plus 2, which is 8 students. How many students took the test? So there's 5 here, 8, 10, 9. So we got to add those up. So 5 plus 8 plus 10 plus 9 plus 6 plus 2. Got to add those up, and you should be 40 students. All right, and that's it for that. So now we're heading to the last sections here, the last 3 sections, or topics. So now we're going to do the empirical rule. So a teacher finds that the test scores of a group of 20 students are normally distributed with a mean of 56 and a standard deviation of 4. Draw a normal distribution and label the numbers under it. Use the empirical rule to label the percentages. Go ahead and do that first. So we got a mean of 56 and a standard deviation of 4. So it's normally distributed, so it's a bell curve. So what I'm going to do is I'm just going to do a bell curve for each problem, but I'm just going to erase the numbers and reuse the bell curve. Okay, so I'm going to draw the best I can here. Okay. So now we got the mean. Mean goes in the middle. And you got your other numbers, 1, 2, 3. 1, 2, 3. Okay, so the mean is 56. Standard deviation is 4, so we're going to be adding 4 to get these numbers. And we're going to be subtracting 4 to get these numbers. And that's what we get, right? So now we're going to label using the empirical rule. Each of these things. So this part right here is 0.15%. This part right here is 0.15%. This part is 2.35%. 2.35%. We have 13.5% here. These numbers will always be the same for any bell curve, you'll see. So it's the same thing. 34% there, 34% there. So those are the numbers from the empirical rule. That takes care of part A. Now, part B is find the probability that a student has a score greater than 64. So a score greater than 64, that means we need to add these two percentages, right? So 2.35 plus 0.15. That's going to be 2.5% or 0.025. I'm going to move the decimal place to the left twice. Okay. All right, so now we're going to do 23, but now we're going to erase these numbers and just replace them with here. The mean is 70, the standard deviation is 6. Okay. All right, so the mean is 70, standard deviation 6, so you're going to go by 6. So it's 6 plus 6 plus 6, so on and so forth. Subtract 6. So we got. All right, and then these percentages will be the same. Like I said, these percentages will always be the same. So part B, find the probability that a student has a score between 70 and 82. Okay, so between 70 and 82. So that means we're adding these two scores between 70 and 82. Okay, so 34 plus 13.5. Okay, so that's going to be 67, or I'm sorry, 47.5. It's going to be 47.5%, which is 0.475 as a decimal. Okay, and that's it for that. So number 24, using the standard normal distribution table. So we're going to be using our standard normal distribution table, which, there's different variations of it. You guys have something similar to this, but most of these tables are going to give you the area to the left. The book gives you something weird. It kind of gives you like, I don't know. The book gives you from here to the 0. I don't know, but most tables give you the area to the left of the z-score. You can see shaded here. So and this is the table, so we're going to be using this. So it says find the area to the nearest thousandth of the standard normal distribution between the given scores. Okay, so well then let's go ahead and find that. Okay, so find the area to the nearest thousand. So we want to find between z equals 1 and z equals 1.9. Okay, so what we want to do is, so first off, we need to know that the standard normal distribution starts at 0 in the middle and it goes by ones. Okay, the standard deviation is 1. That's what we call the standard normal distribution. Okay, so we want the area between z equals 1 and 1.9. Oops. We want this shaded region. So you don't have to graph it, you could just find it. But if they want between two z-scores, you're going to look both of them up and then subtract the areas, okay, on the table. Okay, so we're going to look up for z equals 1.9. The area is equal to, let's look it up. 1.9 is the same thing as 1.90, guys. So really, you're going to want to say, okay, z is 1.00. So we would want to change this to 1.00 and then 1.90. Why do we do that? Well, because the table gives us two, right? You got a first decimal here, and we got a second decimal there. So we want to find out 1.00, or actually, let's do 1.90 first. So 1.90, okay? So then that means it's this area. So 0.9713, okay? So 0.9713, we're going to go back and put that here. And we're going to subtract this from z equals 1.00 when we find the area, okay? We're going to subtract the areas, and that's going to give us our total area for our solution, okay? So we're going to look at 1.00. Remember earlier we looked at 1.90, but now we're going to look at 1.00, 0.8413. And then we subtract those, and that gives us 0.130. 00, but we're going to round it to the nearest thousandth. So that means 3 decimals. And there's our answer. Okay. All right. So now we're going to do 1.81 and then negative 0.48. We're just going to look up the areas from the table. So let's see, 1.81, 801. So 1.81. Okay. 1.81, 0.9649. And now we want negative 0.48. So we can look that up. So we gotta look at the negative side. Negative 0.48. Looks like right there. Yeah. So negative 0.48, 0.3156. 0.3156. We're going to subtract those areas, and we get about 0.6. So we get 0.6493, but then we got to round it to the nearest thousandth, so 0.649. Okay. All right, now we're going to do less than 1.26. Remember, the table already gives us to the left, so all we got to do is just look it up, and that's it. Okay, so we got to look up 1.26 because it says less than, and remember, the table gives us to the left, right? It always gives us to the left by default, which is less than. So let's look up 1.26 on the positive side, of course. So 1.2 and then 6. Right there, so it's going to be 0.8962, and that's it, guys. 0.8962, but we're going to round it to the nearest thousandth, so 0.896. All right, and then this one wants it to be greater than. So now, if the table gives us greater than, then to find the right side, we have to do 1 minus that, okay? 1 minus the area. Okay, so because the shaded side and then the white side, the non-shaded side, add up to 1. So if one of the sides is 0.20, then the other side is 0.80. Okay, so since we want it to be greater than, we need to do 1 minus, essentially. So 2.73, let's look it up. 2.70123. 2.73, okay? So 0.9968. But we got to do 1 minus, okay? Which is 0.0032, rounded to the nearest thousandth is 0.003. All right, and that's how you use the table, guys. So we're going to wrap up with the last section here. So a highway study of vehicles that passed by a checkpoint, speeds were normally distributed with a mean of 61 miles per hour and a standard deviation of 7 miles per hour. How many of the vehicles had a speed of more than 70 miles per hour? So we want more than, which means we're shading where it's to the right, it's greater than, right? So we're going to convert this to a z-score. Remember, z-score is value minus mean divided by standard deviation. So value minus mean over standard deviation, which is 9/7, which is 1.29, approximately. So when we do our normal distribution, we start at 0, we go by ones, and we want 1.29, we want greater than. So we're going to look at 1.29 on the table. 1.29, that's 0.9015. Okay, 0.9015. But that's the area to the left. So if I want the area to the right, I said 1. Okay, so 1 minus 0.9029, which is 0.09. Let me double check that number here. 1.29. 9015, not 9. Okay, 9015. I don't know where I got that. So 0.09. So 0.0985. Okay. So now that's the probability, and then we want how many of the vehicles had more speed of more than 70. We'd have to take this number and multiply it by the total number of vehicles, which is how many vehicles would they say in total? Oh, it doesn't say in here, so it should say 110. See, that's a typo for whatever reason. It didn't show the number of vehicles. So it's going to be 810 total vehicles. So 9.85% of that is going to give us about 79.8, which is rounded to the nearest whole is 80 vehicles. Okay, so that's part A. Now, how many vehicles have a speed less than 42? So we're going to do the same thing. So 42, find the z-score. 42 minus 61 divided by 7 is approximately negative 2.71. Now we want it to be less than, so we're going to look up negative 2.71 to find the area, okay? And we just got to look it up because we want to the left, which, remember, the table gives us to the left. So if it gives us to the left, just whatever the value is, use it for your answer. So we got negative 2.71, 0.0034. There you go, 0.0034. We're going to multiply that. So we're going to do 0.0034 times 810 vehicles, and that's approximately, oops, not 4, about 3 vehicles. Right? All right, and that takes care of number 25. All right, so now it says the test scores of a group of 40 students are normally distributed with a mean of 72 and a standard deviation of 8. So we want 82 or greater. So let's calculate the z-score. So 82 or greater. So 82 minus the mean divided by the standard deviation. And that gives us 1.25. We look up the area. Again, I showed you how to look up the area by now, so I'm not going to show you that again, okay? Well, I guess we could because we're going to need to do a little bit, yeah, we're going to need to do a little bit to it. So since we want it to be greater than, remember, that's to the right. The table gives you to the left, so you got to do 1 minus. So we're going to do 1 minus whatever the table tells us. All right, let's go to the table. 1.25 is 8944. So 1 minus 0.8944 is 0.1056. All right, and then we're going to multiply that by the number of students, which was 40 students. And that gives us approximately 4 students. Rounded to the nearest whole number. You get about 4.2-ish, rounded down to 4. What is the percentile for a score of 76? Percentile, that means the area to the left. Okay, so this means to the left. That's asking for what the table already gives us. So let's convert 76 to a z-score. So 76 minus the mean is 72. Standard deviation is 8. So it's going to be 0.50 for our area. Okay, so let's look at the area. 0.50, 0.6915. 0.6915. That's the area to the left, so we're good. We're going to convert it to a percent, so 69.15 15th percentile, which is about approximately 69th percentile. Okay, all right, good. So now 27. It says they found that the attendance at its home games is normally distributed with a mean of 16,000 and standard deviation of 4,000. What percent of the home games have an attendance between 12,500 and 18,000 people? All right, so convert this. We have 2 z-scores we want to convert to. So I'm going to do z1 and z2. So we're going to do 12,500 first, minus the mean. It's always value minus mean, right? We've mentioned that before. Value minus mean divided by standard deviation. So you get negative 0.88. Let's compute the second z-score, which is for the 18,000. That minus the mean divided by standard deviation. So 0.50. So 0.50, excuse me, let me just rewrite that. Excuse me. So 0.50 is your z-score. So now we're going to convert this, we're going to convert these to areas. So when you look it up, and then we'll look it up and then subtract. So negative 0.88. This is 80, 81, 82, 83, 4, 5, 6, 7, 8. Negative 0.88. So 0.1894. Okay, and then 0.50, we looked that up earlier. Where did we found that earlier? It's 0.6915. So 0.6915. You're going to subtract those, okay? Obviously, it's bigger minus the smaller. So 0.5021. And you got to convert that to a percent, so that's about 50.21%. Okay? So now here, part B is what is the percentile for an attendance of 15,000 people? So again, this is the area to the left. So we're going to do 15,000 minus the mean over the standard deviation. That's gonna be 0.25. We're gonna look it up to get the area. 0.25 to 5, so 5987. Move the decimal to the right, so 59.87, which is approximately 60th percentile. Alright guys, that's gonna do it for the video. If you found this useful and informative, as usual, I'll see you in the next one.